the chain rule. If y is a function of u and u is a function of x, then the derivative dy by dx is equal to dy by du multiplied by du by dx. Or we could say dy by dx is equal to the product of dy by du and du by dx. If we consider this one over here, y equals x plus 2 all to the power of 4, we can say that y is a function of x. So if we let u equal this bit in the brackets, x plus 2, we can then say that y equals u to the 4. Look, here we have the same structure. Y equals something to the power of 4, and here y equals something to the power of 4. It's the function of a function. So y is now a function of u, and u is a function of x. The new variable u is the link between the two expressions. Let's take this as our first example. We're going to find the derivative of this function. So first of all, if we say let u equal x plus 2, then that will give us y equals u to the power of 4. Now if we do dy by du, that is differentiating this y with respect to u, we get 4u cubed. Similarly, if we differentiate this here with respect to x, that is du by dx, we get 1 from that x term there. And then the chain rule says dy by dx is equal to the product of dy by du and du by dx. So in this case we get dy by dx equals 4u cubed multiplied by 1, which of course is 4u cubed. If we substitute u equals x plus 2 into this, we get our final answer, dy by dx equals 4 brackets x plus 2 all to the power of 3. This is the required derivative of our original function. Example 2, differentiate 3x plus 2 all to the power of 4. First thing I'm going to write is let y equals my function here, 3x plus 2 all to the power of 4. By writing this, it means I can correctly write the value of dy by dx later on. Well, first step is to say let u equal 3x plus 2. That is what's inside the brackets here. Then I can say that y equals u to the power of 4. And remember the chain rule, dy by dx equals the product of dy by du and du by dx. So we're going to work out these terms. Dy by du is the derivative of this with respect to u, so that's 4u3, and du by dx is the derivative of this here with respect to x, so that's 3. Therefore dy by dx is the product of these two terms, so that'll give us 3 multiplied by 4u cubed. And we know that u is equal to 3x plus 2, so if we make that substitution and do the product of 3 and 4, which is 12, our final answer is dy by dx equals 12 brackets 3x plus 2 all to the power of 3. Example 3, differentiate x squared plus 3x all to the power of 7. First thing I'm going to do is let y equal my function x squared plus 3x all to the power of 7. And then I'm going to say let u equal the bit in brackets here, x squared plus 3x. And that allows me to say then y equals u to the power of 7. And remember, the chain rule is dy by dx, or the derivative, is equal to the product of dy by du and du by dx. So let's work out these two terms here. Dy by du is the derivative of this here, so we get 7u6, and du by dx is equal to the derivative of this here, so that's 2x plus 3. And now I can write my expression for the derivative dy by dx. Dy by dx equals the product of these two, so I've got 7 lots of these two multiplied together. Now it's important that I write this one in brackets so I don't make a mistake when I'm multiplying, because it's this whole term here which is equal to this whole term here. So I'm going to do 7 2x plus 3 u to the 6, and then of course I'm going to substitute in u equals x squared plus 3x, and that's going to give me dy by dx equals 7 brackets 2x plus 3, close the brackets, another pair of brackets, x squared plus 3x to the power of 6. I'm going to leave this in its factorized form. Example 4, differentiate 1 over 1 plus root x. Well, the first thing I'm going to do is say let y equals this function. But I'm going to rewrite this so it's much more familiar in terms of the chain rule. So I've got a quotient here, 1 over. Well, because there's only a constant on the top, I can write this 1 plus root x in brackets, and that's going to be to the power of minus 1. I can also note that root x is equal to x to the power of a half, which is again going to ease things a little bit in a moment. So if I say let u equal what's in the brackets, that is 1 plus, I think I'm going to use x to the half as a way of expressing root x here. Then I can say that y equals u to the minus 1. And remember, let's recall the chain rule. Dy by dx is equal to the product of dy by du and du by dx. Great, let's work these out then. Dy by du is equal to minus 1 lots of u to the minus 2. The product of these two things here. And du by dx is equal to the derivative of this bit here, so that's going to give us a half x to the minus a half. And now I've got these two terms, I can work out the value of dy by dx, or express it. So I get minus 1 times a half, so I'll get minus a half lot of x to the minus a half multiplied by u to the minus 2. But remember, u equals 1 plus x to the half. So in here I've got 1 plus x to the half, and that's all to the power of minus 2. Well, this is okay. That'll get me full marks in an exam, I'm sure. However, it might look neater if I express dy by dx as minus 1 all over 2 root x brackets 1 plus root x squared. Example 5, differentiate 1 plus x squared all square rooted. So here I'm going to write let y equals this function here. But remember that the square root of something is equal to the power of a half. So I think it's going to be easier for me if I write 1 plus x squared in brackets, and instead of the square root I do its equivalent as a power, which is the power of a half. Now I can say let u equal the bit inside the brackets here, that's 1 plus x squared. Then y will equal u to the power of a half. Now remember the chain rule. dy by dx equals dy by du multiplied by du by dx. Let's find these two terms. dy by du is equal to a half u to the power of minus a half, and du by dx is equal to 2x. And now I can say that dy by dx is the product of these two terms. Now if I remember that the substitution that I want to make to get back is u equals 1 plus x squared, and I'll put that straight in here. So that's going to give me a half, and the 2x, and substituting this in for u will give me 1 plus x squared in the brackets, and a minus a half there as well. Of course, a half times 2x is x, so I might want to rewrite this a bit neater as x over the root of 1 plus x squared. There we go.